Jai Bharat to all students. In last lecture, we have discussed another definition related to the graph theory, like null graph, complete graph, cycle graph, field graph, path graph, bifurcated graph. Okay, so in today's lecture, we will talk about how to solve different types of puzzle with the help of graph theory. Okay, different types of puzzle with the help of graph theory. Okay, we all know that sometimes puzzle is difficult, and for the normal procedure or any method, it's difficult to solve puzzle. Okay, so for that type of puzzle we can solve with the help of graph theory also. Okay, so in this lecture we will discuss three different types of puzzle, and we will solve this that types of puzzle using the graph theory. Okay, first, the 8 circle problem. Okay, it's name said 8 circle problem. Okay, what is the question said? That place the letters A, B, C, D, E, F, G, H, okay, into the 8 circle in the figure 1.5. We have to place the 8 into circle in such a way that no letter is adjacent to a letter that is next to it in the alphabet. Adjacent means near. Okay, in the alphabet we have seen that A is nearer with the B, so we have to put like A and here B. Okay, sorry, this is wrong. B is adjacent to the A, B here. Okay, and C to the D. Okay, here E and here F. Okay, then okay, like this. Okay, so for how can we solve this using the graph theory? Okay, we have to put this in the circle. Okay, first of all, how many possibilities? There is a 40,320 possibility that we can put the letter in the box. Okay, but our condition is that no letter is adjacent to the letter that is next to it in the alphabet. Okay, simple. First of all, here our simplest letter is should be A and H. Yes, why? Because A and is only adjacent to the one letter. In other letters is connected with the both front and back. Okay, C is connected with B and D also. Okay, so our easiest letter will be A and H, and our difficult letter will be center, middle, which is connected with the both. Okay, so first of all, what we do, we put A and H into the graph. Okay, now here you can see that this circle is connected with how many circle? 1, 2, 3, 4, 5 and 6. Okay, so if we put any letter in this circle, this is connected with all the 6 letter. Okay, so and this circle also connected with the 6 edges. Okay, so if we put any D here, now if we C and E should be not nearer to the D. Okay, so we can put only C here, not any other. E can if we put any circle in E, it will be adjacent to the D. Okay, so for these two circle have 6 common, so what will we do? We will put A and H into this 2 circle. Okay, why? Because it's only connect, we have to do the it's not nearer to the B and G respectively. Okay, so we will put here A and H, or vice versa, you can put H and A also. Okay, now what is the nearer to the A? B. Yes, so we will not put B in this any of this adjacent to the A leg. So one circle is remaining this. so we have to put the B in this circle. All other circle are not possible. Why? Because A is adjacent to that circle, and also H is nearer with G. We only one circle is there, that H is not adjacent to the G. So 4 circle are complete. Okay, now it's a easy one. Okay, uh, what letter are remaining? C, D, E, F. Okay, C is nearer with B and D. Here B is nearer with C. So C we can put in here or here. Okay, anything C. Okay, then D. D is nearer with C and E. So we cannot put D here. We can put D here. Then E is near with D and F. We can put here E. Okay, and F is near with E and G. Sorry, so we have to put F here and E here. Okay, so let's it's right or wrong. E is not nearer with D and F. D is not nearer with C and E. Okay, sorry, here also mistake. Okay, so what first of all we have to put the D in here. Okay, now E is not near with D and F, so we will put E here, and F is not near with E and G, so we will put okay, right. Okay, so this is the 8 circle problem using the graph theory. Okay, condition is no letter is adjacent to the letter that is next to it the alphabet. Okay, so first of all they have put main 4 letter. Okay, then it's easy to put this in any form. They have put a C in the like, oh sorry, A and H they have put alternate. Okay, you can anything you can like. Okay, so okay, now second puzzle. 6 people at a party, so that in any gathering of 6 people, there are either 3 people who all know each other. There are either 3 people who all know each other. Okay, as all know A is known to B and B also knows to A, or 3 people none of whom knows either of the other 2, means 3 people do not know other 2. Okay, and B does not know each other. Okay, so these are the only 2 possibility. Okay, we have to show them. How we are gonna just show that. Okay, so let's start with, we draw a graph in which we represent each person by a vertex. Okay, now let's join join 2 vertices by solid edge if the corresponding people know each other. Join vertices by a solid edge if corresponding people know each other, and by a dotted edge if not. Okay, if it do not know each other, then we will draw with the dotted edge. Okay, so we must show that there is always a solid triangle. Why? Because 3 people we have to know each other. So A, B and C. So if A knows B, A knows B, A knows C and B knows C, so this will become solid triangle. And if none of them knows, then it will become dotted triangle. Okay, so we have to show that there is always one solid triangle and always one dotted triangle with the possibility. Okay, with the different possibility. Okay, yes, they said that they 3 people know each other, so it's meaning that it's in graph there is a one solid triangle, and or 3 people none of them who knows either of other 2, so one graph should be, it's either solid triangle or either is a dotted triangle, then this theory is going to be true. Okay, so now let V be any vertex, then there must be exactly 5 edges incident with V, it's either it's know him or do not know him. Okay, either solid or dotted. Okay, so now, so the at least three of these edges must be of the same time, is either know him or not know him. Okay, let us assume that there are solid edge. You can also assume there is a dotted edge. Okay, so at least the three of these edges must be a same time. Okay, so they have given three edges as a solid. You can make any this solid also. Okay, it's not a problem. Okay, the case of at least three dotted edges also similar. Okay, we have now assumed that three are solid edges. Okay, now if the people corresponding to W and X know each other, if people know each other, then V, W and X make triangle. Yes, possibility number one. Here our triangle is bad, so our first theory, either three people would know each other, is going to be true for the first experiment. Okay, now let's say if the people corresponding to vertex W and Y, W and Y people know each other. Okay, so this will become again V, W and Y triangle. So this possibility is also true for our theory, three people know each other. Then let us assume X and Y know each other. X and Y know each other. Then we again obtain the solid triangle. Yes, V, Y and X. So this three possibility, three experiment, we saw that there is always a possibility that one solid triangle is performed. So what is the meaning of one solid diagram? That three people know each other. It's our theory, three people would know each other. Okay, yes. Okay, now say if no two of the people corresponding to the vertex W and X and Y know each other. W, X and Y do not know each other. W and X and W and Y do not know each other. Then we can see that W, Y and X form dotted triangle. Okay, so our second theory, people, none of them who knows either of the other two, is going to be true. Okay, so in any party, any gathering of six people, there are either three people who know each other or three people, none of them who know either of the other two. Okay, so with the help of graph we can show that this statement is true. Okay, so this is a second puzzle over. Okay, now third puzzle, 4 cubes problem. Okay, now given 4 cubes whose faces are colored red, blue, green and yellow. There are 4 cube and all the cube are colored with the red, blue, green and yellow as shown in the figure, like this: cube 1, 2, 3 and 4. Okay, this is the front side, this is the left side, this is the right side, this is the bottom side, and this is the, what do we do, front size and back size. Sorry, this is the front size and this is the back side. Okay, okay, so now we have to pile them up like this so that all 4 color appear on each side of the resulting 4 one side. Okay, all the color appear on each side. Okay, so this is a, if say this is a front side, there is a all the 4 color has to be available, and this is the left side, all the 4 color is available in this, and the back side also, and right side also. Okay, so if you pile them up of this 4 cube, you have to visible all the 4 color, all the 4 color that you have to put them up: cube 1, cube 1, cube 2, cube 2. Okay, you get it the example. What do they will say that all four colors appear on each side of the resulting 4 by 1 set. If you seen from the front side, all the four color you should be visible. If you seen from the back side, all the four colors should be visible. If you see from the front left side, all the four colors should be available. And if you see from the right side, all the four color has to be available, visible. Okay, red, blue, green, and yellow. And that tab you have to put up in a pile them up. Okay, cube 1, 1, 2, 3, 4. Okay, so how do we do? Okay, we will use the graph theory. Okay, first of all, this cube can be stacked in the thousand of different way. Okay, there is essentially only one way that gives a solution. There is only one way that we can see the all the color from any side. Okay, so first of all we transfer this cube into a graph. Okay, so we represent each cube by a graph with a 4 vertices: red, blue, green, and yellow. Okay, one for each color. Okay, we convert this into 4 vertices. Okay, in each of this graph, 2 vertices are adjacent if and if the cube in question has the corresponding colors on the opposite face. Okay, what is the condition we have to transfer? Okay, opposite face means here cube 1. What is the opposite to the yellow? It's a blue. Why? Because it's appear as a top and bottom. Okay, what is the opposite to the this red? Front, and this is a back, this is a front. Okay, so opposite to the red. So in graph we have to represent that red and red is nearer. Here y yellow and blue is nearer. For red and green also is a nearer, adjacent. Okay, so we have to join with the edge. Adjacent means we have to connect it with the edge if it is a opposite to the face. Okay, opposite faces, if this is the opposite faces. Okay, so first of all, here red, blue, green, and white. Okay, what is the opposite to the this? First of all, we will start with the top y. Opposite to the top y is the bottom blue, so we have to connect y and b. Then red, front, back and front, red to red, so we have to draw loop. Then left and right, red and green, we have to join with the edge. Cube 1 is completed. Then as well as cube 2, top y and bottom green. Okay, so top y and bottom green joining with the edges. Then red and yellow, red and yellow with joining with edges. Then red and blue joining with edges. Cube 3 done. Cube 3, blue to the opposite y, so it's a joining with the edge. Green is opposite to the green, so it's a joining with the loop. Blue is joining with the R, blue is joining with the R. Cube 3 done. Cube 4, yellow is opposite to the green, so it's a joining with edge. Here blue is opposite to the yellow, so it's a joining with the edge. And red is opposite to the green, so it's joining with this G. Okay, so now we have transferred all 4 cube into the graph. Okay, and condition is that if 2 vertices are adjacent, nearer, if the cube in question has the corresponding to the opposite face, same. Okay, opposite color on a opposite face, and these 2 color are adjacent, joining with the edge. Okay, now we will compile all these 4 graph into one graph. Okay, so we superimpose this graph to form a new graph G. Okay, so we will we have make new graph. Okay, now we have to pile them up, cube 1, 2, 3, 4. Okay, so we have to choose subgraph from this main graph. Okay, Okay, now how do we choose subgraph? Okay, now first of all we have to choose two subgraph. Okay, why two subgraph? From front and back and left and right side. Okay, there is a four phase. Okay, so we have to choose two subgraph which has a front and back and left and right. So let's say H1 and H2. H1 tells us which pair of colors appear on the front and back of each cube. Okay, and the subgraph H2 tells us which pair of color appear on the left and right, front and back and left and right, H1 and H2. Okay, we must have to find out H1 and H2 from this cube. Okay, so first of all find out the about cube. So we will write down vertex red, blue, yellow and green. Okay, we have to make the subgraph of H1 and H2. Okay, now what is the condition? First of all, there has to be exactly one edge. Why exactly one edge? Because front and back has only one color, should be red, green or blue, gray. There is a no multiple edges. Okay, exactly one edge. There is a no loop also. Okay, because we have to show that red is appear in this side and this side also. Okay, so there is a no edges in common and no loops is there. And also subgraph is a regular of degree 2. Why degree 2? Because we have to pile them up as a cube and we have to show that all four colors appear on the each side. Okay, so there is a always going to facing with the only two vertex, or sorry, opposite to the two vertex. Okay, so it's always going to be only degree of vertex 2. Okay, so how this three condition has to be followed: one edge, no loop, and degree of vertex going to be 2. Okay, so first of all front and back and left and right. Okay, for red and blue, how many edges are there? Two edges, 2 and 3. This edges is said cube. Cube 1, this cube 1. Okay, this two number of edges is from the cube 2, cube 3 and cube 4. Okay, so I forgot that to tell you that this 4 is representation of cube 4. Okay, so now for red and blue, connected with the opposite side is a cube in cube 2 and cube 3, 4, cube 2 and cube 3. Okay, so let's assume that we will put this cube 3 here and cube 2 here. Okay, so here cube 3 here and cube 2 here. Okay, sorry, this is a cube 3 here, front side is and back side is this, and left side is this, and right side is this. Left and right is opposite to each other, front and back is also opposite to each other. This is the 3D image. Okay, so do not confuse them. Okay, so we have now put cube number 2 and cube number 3 in the position, cube number 3 and 2 in position of the front and back subgraph. Okay, then here for red and green also we have two cube number 1 and cube number 4. Okay, so what we'll do, we will put here 4 and here cube number 1. Okay, then here 2 and 4 cube. Okay, so 2 and 4. Okay, we will decide that this is a 4, so we will not put this in the 4 number of cube because this will be same. So 2 and 4. Then we have now here 3 cube, 1, 3 and 4. Okay, so now it's easy. What cube will remain? This is a 1 remaining, here 3 remaining. Okay, so for trial and error you have to choose front and back and left and right. Okay, so now we have to make the pile. Okay, for cube 1, here cube 1, front and back is a blue and yellow. front blue and yellow. Here front and back, blue and yellow is opposite to each other, so it's a joining with the edges. Then cube 2, green and yellow. Cube 2, green, yellow. Yes. Then cube 3, red and blue. Cube 3, blue and red. Cube 4, red and green, red and green. Yes. Then left and right. Cube 1, it's a opposite to the red and green. Cube 1 is opposite to the red and green. Then cube 2 is opposite to with the red and blue. Blue, red. 3 is blue and yellow, blue and yellow. 4 is green and yellow. Okay. So now if you see cube from any side, you will see all the 4 color. Okay. Green, yellow, blue, red, red, blue, green, yellow, yellow, blue, red, green, green, red, yellow and blue. Okay. Left side, front side, right side and back side. Okay. So from this graph theory, we can easily identify this puzzle, solution of this 4 cube problem of this puzzle. Okay. So now for today's assignment question, you have to solve this question. Okay. As a same as a, you have to put the cube and pile them up, and from each side all the 4 covers should be visible. Okay. So for this problem you have to solve 4 cube problem for your assignment. Write it down and upload it in RNWIET application. So today's lecture is completed.